Hello friends, in this video we are going to know about the EMF equation of the transformer. Actually, this is the primary winding and this is the secondary winding. This is the core part which was made up of iron and which was gets laminated with silicon steel. Okay, what is the purpose to find the EMF equation means when we are providing the alternating voltage to the primary winding, the I1 current get induced and it creates the alternating flux and also induces EMF E1. When the alternating flux reaches the secondary winding, it induces the EMF E2 and the E2 is named as mutually induced EMF. To find the magnitude of this EMF, we have to derive EMF equation. So only we can able to find the E2 magnitude. Okay, and look at this space diagram. I'm taking um, flux and frequency. Okay, we are providing the alternating voltage, right? So the waveform should be like that, and one up and down is named as a cycle, and one cycle it takes 360 degree, and the flux from 0 it reaches its maximum peak 1 quarter. So we all well known about that time is equal to 1 by f. So there is a change in the flux, right? From 0 it reaches its maximum flux. The maximum flux is denoted by flux base m. Okay, it reaches its maximum value at 1 quarter of cycle. So we have to find the average rate of change of flux. Average rate of change of flux equal to pi m by t by 4. Okay, actually t is equal to 1 by f, right? So how we write this means this is equal to pi m divided by 1 by 4f, right? So and when the 4 is going to the numerator, and our answer will be like this, and this is a Weber second. We have to calculate flux in by using this unit Weber. Okay, in order to find the EMF which was gets induced in both primary and secondary, we have to find how much amount of EMF is induced per turn. Then only we can able to find how much of EMF gets induced in both primary and secondary coil. For this, let me give the notations, and N1 is the number of turns in primary winding, and N2 be the number of turns in secondary winding, and pi m is the maximum flux, right? Okay, and f is the frequency of AC supply, and V1 is the voltage which gets passed in primary winding, and V2 is the voltage in secondary winding, and I1 is the current which gets passed to primary winding, primary winding, and I2 is the current is the resultant current from the secondary winding. So these are the notations. So we find the average rate of change of flux. This is a per turn, and the answer is 4f fluxium Weber second. Otherwise we use the unit volts. Okay, we find the EMF induced in per turn. And the second step is to we have to find how much amount of EMF gets induced in primary winding as well as secondary winding. um, uh, to rate the amount of EMF, we have to use the RMS value by okay. And for due to this alternating current, the RMS value for the sinusoidal wave will be like that. So the form factor is equal to RMS value divided by average. So we have to describe the answer of the EMF, how much amount we get with the RMS value. Okay, so we need this RMS value only, right? So form factor into average. For the sinusoidal waveform, the form factor has a constant value. So the form factor is equal to 1.11. So the RMS value of the EMF per turn is 1.11 into 4f pi m. Okay. According to the formula, form factor into average, that is equal to RMS value, right? So the RMS value is equal to form factor 1.11 into average EMF. What we find here is 4f pi m Weber second. So that only I noted here. Okay. Okay, now we have the value how much EMF gets induced per turn. We have to find how much, what is the RMS value will be for the primary winding as well as secondary winding. For this, RMS value of EMF is induced in primary winding, that is E1 is equal to RMS value what we described so far of per turn into number of turns present in the primary winding. Okay, so we have to multiply the RMS value per turn with number of turns in the primary winding. Then the E1 is equal to 4.44 f n1 pi n. Okay, after multiplied with the number of turns, okay, the notation for the number of turn in primary winding is n1. So after multiplied we get the answer. So now we have the EMF which gets induced in the form of RMF value. For the secondary winding, similarly for the secondary winding, the RMS value of EMF, that is E2, is equal to RMS value per turn into number of turns in secondary winding. After multiplied we get the answer like that, 4.44 f n2 pi m. So n2 is the notation to represent number of turns in the secondary winding. Okay, so the EMF equation of the transformer is E1. This after getting the n1 to the left side is equal to similarly E2 divided by n2 is equal to 4.44 f n1 pi m. So this is the EMF equation. So this is the equation of EMF of a transformer. I hope guys you all are understand the EMF equation of the transformer, how it's get derived.